Okay, so for 4-5, isosceles and equilateral triangles, these are the two types of triangles we will mostly be using. We'll learn more about right triangles in topic 10. But for isosceles triangles, we can see here, an isosceles triangle, I just have I triangle. It has two equal sides and two equal angles. Now, the way I always like to think about it is the two equal sides are pointing at the two equal angles, okay? So even if this triangle is sideways, if these are the two sides, these are going to be the two angles, okay? We call the two sides that are congruent the legs, and we call the part that has the two congruent angles the base, okay? So the legs are pointing at the two congruent angles, okay? And this is how the isosceles angle theorem works. If two sides are congruent, then two angles are congruent. And the opposite works too. If I start out with two angles that are congruent, well, they're going to point to the two sides that are congruent. If one is true, the other's true. If it has two congruent sides, it has two congruent angles. If it has two congruent angles, it has two congruent sides. That's how this works, okay? That's what this is saying, these if and then statements and the converse of that. Now, something very important is talking about angle bisector and perpendicular bisector. And so that's right here. This is a special case on an isosceles triangle. We'll learn more about angle bisectors and perpendicular bisectors and whatnot in chapter 5. That's a very bad drawing. But in general, this is a special case scenario, okay, where if this line that's going down this triangle, okay, this big triangle is an isosceles triangle. If we ignore that line, we have an isosceles triangle. So we know that these two angles are going to be congruent, right? This side is pointing to that angle. This side is pointing to that angle. And then we just have this line cutting it in half right here, okay? And it is cutting it in half because these angles right here are congruent. So that makes this line an angle bisector. And then it also forms a right angle with the base, okay? So it's a perpendicular bisector. And meaning it's a bisector, it also cuts this side in half, okay? So this part is congruent to this part. So there's a lot of things that happen here. And so we say angle bisector, perpendicular bisector. The angle gets cut in half, the side gets cut in half, and it's perpendicular, so it's forming a right angle, okay? This is special on isosceles triangle. Angle bisectors are not always perpendicular bisectors, but on an isosceles triangle, they are. And it forms two right triangles. So this is one right triangle, and this is another right triangle. And both of these triangles are congruent because they have all three equal angles and all three equal sides, because this side is the reflective property. And so because of that, we know that these two triangles are congruent inside of this larger isosceles triangle. So now let's talk about equilateral triangles. Equilateral triangles are pretty simple. There's nothing much to them. They have three equal sides and three equal angles. And if we know triangles equal 180 and all three angles are the same, okay, let's call all three angles x, then I can just divide this by 3, and I know that every single angle in every equilateral triangle is always going to be 60 degrees. That's never going to change, okay? So if we were like, this is, in an equilateral triangle, this is 10x degrees. What is x? Well, 10x must equal 60, so x must equal 6. And it's that simple. That's how problems with equilateral triangles are. If all three angles are congruent, then all three sides must be congruent, and the reverse is true as well. If all three sides are congruent, then all three angles are congruent. For the types of problems that we're doing, for the example problems, oftentimes you might see where the triangles are put together, okay? So we have, if these have two equal sides, then in this smaller triangle, remember, always cover up any sides that we're not using, then these two angles must be congruent right here, angle DAE and DEA. So I could like mark on there with a pencil that angle is also congruent. Well, now let's ignore that middle line, and this big triangle, I can see this angle and this angle are congruent. Well, if a triangle has two congruent angles, then this whole side is congruent to this whole side. I'm going to put double dash marks there. So we have a bunch of congruent shapes, and then we can answer these questions. Is AB congruent to CB? Well, yeah, we proved that because of the converse, because it's an isosceles triangle. And so we could just say isosceles triangle. So the other type of problem that we would see is if we have this problem and 54 degrees, I know it's kind of hard to tell, that's in here, okay? And then we know if this is an angle bisector, this must be a perpendicular bisector because this is an isosceles triangle. So now if we know triangles equal 180, I know that 54 plus 90 plus x, because this is the same in both triangles, plus x must equal 180, and then I can solve for x, okay, to figure out what the missing angle is. And they do that here, so if you want to pause the video and look at the example there. Like I said, equilateral triangles are really simple. The angles are always going to be 60, and so just make sure you're reading the question properly. And then the questions start on the next page. Make sure you're writing your reasons for how you're solving it, either isosceles triangle, equilateral triangle, angle bisector is a perpendicular bisector, triangles equal 180, and we're also using straight lines equal 180. That's something to keep in mind. One thing I do want to note is always cover up things you're not using. If you're solving for this left-hand triangle, cover up the right-hand triangle. If you're solving for the right-hand triangle, cover up the left hand. And the way that we solve these problems is I know if this is an equilateral triangle, I know that both these angles are congruent. So both of these are going to be 50, and we can find the missing one. Same thing here. If I know both these sides are congruent, then I know both these angles are congruent. They're both going to be y. I can say y plus 100 is going to equal what? Well, triangles equal 180, so it must equal 180. And then I can solve that problem for what y is. Pretty much, I subtract this, subtract 180 minus 100, and then divide by 2. So y must be 40. I just did a problem for you guys. So that's what 4-5 isosceles and equilateral triangles are all about.